Hello everybody and welcome back. Root Beer here looking at question number 15, our penultimate question on the 2017-18 Part 1 Alberta Math Contest. Quite a mouthful every time. A positive integer is called a palindrome if it remains unchanged when written backwards and forwards. Okay, so 1, 2, 3, 4, 3, 2, 1 is a palindrome. Okay, because if I wrote it in reverse, I'd get the same thing. 101 is a palindrome, 99 is a palindrome, 444444 is a palindrome. Okay. Find the number of 5-digit palindromes which are divisible by 55. Okay, 5-digit palindromes divisible by 55. So this is a question involving divisibility rules, and so it's a good idea to know divisibility rules. Okay, so quick note, a number, usually you break it up into prime factors, so a number is divisible by 55 if it is divisible by 5 and 11. And there are rules for how to test if you're divisible by 5 and 11. For example, a number is divisible by 5 if it ends in a 0 or a 5. Now, imagine a 5-digit palindrome. If we put a 0 at the end, because they're read the same forwards as backwards, we'd have to have a 0 at the beginning. Is that going to be a 5-digit number? Well, no, we don't really count leading ones. Okay, so since you can't have a 0 at the end, because that would mean a 0 at the beginning, we must have a 5 at the end, and therefore a 5 at the beginning. We've got a few more digits to work out, but this is going to be the pattern. So we really only have the two in order to make this divisible by 11. We need to know what could A be, what could B be. Okay? So divisibility by 5 is one that you've likely come across. Okay? Just like divisibility by 2, it has to end in 0, 2, 4, 6, or 8. Divisibility by 3, you add up all the digits, and if that total is divisible by 3, then the original number was divisible by 3. But things like 11, 13, 7, these are not as common. Okay? With 11, what you do is you form an alternating sum. Okay? And if that turns out to be divisible by 11, then the whole thing is divisible by 11. So, for example, let's say 100, let's say 400, I really need to think of a good number, 539. 539 is 49 times 11. Okay? I know it's divisible by 11 because if I take the 5... Oh, sorry, I need to start my alternating sum with a minus sign. I knew something felt off. 5 minus 3 plus 9 is 11. Is 11 divisible by 11? Yeah, so the original number is. 98. Now, 98 isn't divisible by 11. Right? It's not 99. But if I do 9 minus 8, I get 1. 1 isn't divisible by 11, so I know 98 isn't. Okay? So this is what we need to check. Okay? Based on what A's and B's make this value divisible by 11. Okay? So we got 2 minus A's, we got a plus B, and we've got 2 plus 5. So we get 10 minus 2 plus B. We need 11 to divide that. Okay? Now, if 11 divides this, then 11 divides this minus 11. There's a reason I'm doing this for a moment, but if you take a multiple of 11 and subtract another multiple of 11, or add a multiple of 11, you still get a multiple of 11. So the reason I do that is to change this 10 into a minus 1, because I think this is going to be a little nicer to work with. So B minus 2A minus 1 needs to be a multiple of 11. And as long as I can pick B's and A's that do this, I will get multiples of 11. And since I've got those 5's at the end, I will have multiples of 55. Okay? Now, B and A are single digits. B has to be, and they can be 0. Only the leading digit couldn't be 0. So B could be 0. A could be 0. A could be as big as 9. So 2A be between 0 and 18. Okay? And B and A don't really have anything to do with each other, so you could take something that's as big as 9 and subtract off something that's as little as 0. Okay? Or you could say B as small as 0 and subtract off something as big as 18. Okay? And then we could subtract off this 1 from all sides. So I know B minus 2A minus 1 needs to be somewhere between 19 and 8. Okay? What multiples of 11 are in there? Well, negative 11, 0, and that's it. Okay? So we've got two different cases. If B minus 2A minus 1 is 0, then B is 2A plus 1. As I said already, A is a single digit. And we're not going to need to finish this thing off, but 2A plus 1, is that going to be a single digit? Because B has to be a single digit as well. Well, we get 1, 3, 5, 7, 9, 11. B can't be 11 or 13 or anything else. So this gives us 5 pairs, A and B, and so it gives us 5 numbers. So for example, 5, 1, 3, 1, 5. And this should be divisible by 55. All right, dividing it by 5, we'll get 1, 0, 2. We'll be left with 3, bring down the 30, so 6. And a 3 there. And then is this quotient divisible by 11? 99, 3, 6. Yeah. So it's divisible by 5 and 11, so it's divisible by 55. Okay? So we get 5 different pairs. I'm just going to highlight this for easier lookup a little later. So 5 different possible A and B, and all of these would work. So 5, 4, 9, 4, 5 is a multiple of 55. Okay. But then there's the possibility that B minus 2A minus 1 is negative 11. Now if I add the 1 to both sides, B minus 2A is negative 10. B plus 10 is 2A. Okay? So B is a single digit, so B plus 10 has to be somewhere between 10 and 19. And then dividing, we would need to get A. You need to divide by 2 to get A. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so 10, 11, 12. But you'll notice only some of these will work. Because only some of these could be equal to 2 times A. So A could be 5, or, well, not going to work. A could be 6, 7, 8, 9. And so we get 1, 2, 3, 4, 5 more possibilities. Possible pairs. Right? So these 5 here, that should be 10 different numbers. And that's our middle answer, C. 10 such numbers, C. And there it is. Okay. Question number 15, all squared away with. Up next, we're going to take a look at question number 16 and finish off our little Alberta paper. Okay?